Yeah, good evening. Welcome to the video lecture of electric field industry due to volume charge distribution. Okay, so electric field intensity due to volume charge distribution. Okay, right. So in the last class we discussed about electric field intensity due to infinite sheet of charge. So in this class we are going to discuss about electric field intensity due to volume charge distribution. Okay, so volume charge distribution means charge will be specified by volume charge density rho v. Okay, so this is the volume v with charge density of rho v. Okay, right. So now let us say this is a sphere of radius is equal to a. Okay, so this entire sphere is radius is having radius of a. Okay, right. So now inside the sphere we consider the small differential volume dv. So this is dv, small differential volume, and let us say dv is having reference at r dash comma theta dash comma phi dash. So this is the reference. Okay, so from this reference as this is the differential elemental volume dv, which is referenced at r dash comma theta dash comma phi dash, this distance from origin, so this is nothing but your r dash, and this angle is theta dash. Okay, right. And now, so from the reference point we have drawn a vector to the point of interest 0 comma 0 comma z. Now P is the point which is 0 comma 0 comma z, at which we would like to find out the electric field intensity due to this volume charge distribution. So this vector is our r bar. Okay, so as this point is 0 comma 0 comma z, this is origin, this height will be z. Okay, right. So what we have done is we have considered a volume which is a sphere of radius a, and inside that volume we considered a small differential volume dv, which is having its reference at r dash comma theta dash comma phi dash, and then we have drawn a corresponding distance vector to the point of interest p. Okay, and now from this figure we need to write down some important things, and first thing what we would like to do is dv. So what is dv in this case? So because this is a small differential elemental volume, in terms of these coordinates, dv is for spherical coordinate system r dash square sine theta dash dr dash d theta dash and d phi dash. So this is the expression for differential elemental volume dv. Okay, and from this figure, so if I draw this figure like this, this is origin, this is the point P, which is 0 comma 0 comma z, and this is the reference, which is r dash comma theta dash comma phi dash. So this distance is r dash, this angle is theta dash, and this is the vector r, and let us say this angle is alpha. Okay, right, and this is alpha. Now using this triangle, and we can clearly say this triangle is not a right angle triangle. So using this triangle, what we can write down is r square is equal to, and this distance is z, r square equal to z square plus r dash square minus 2z r dash cos theta dash. So that will be equation number 2. This is using the cosine rule. Similarly, we can write r dash square is equal to z square plus r square minus 2zr cos alpha. So there are the two equations what we can write down from this triangle. And if you see, look at from equation number 2, so if I differentiate equation number 2 with theta dash, so what I will get is 2r dr by d theta dash is equal to 2z r dash sin theta dash. So because on this side I am having a minus, if I differentiate cos theta dash I will get minus sin theta dash, so it minus into minus plus. So from this we can write down sin theta dash d theta dash is equal to, so what I get is 2 gets cancelled, so I will get capital R dr divided by z r dash. So it will be equation number 4. And similarly from equation number 3 I can write down cos alpha as cos alpha is equal to z square minus r dash square plus r square divided by 2zr. So this is what I can write down from cos alpha. Okay, and right, so having written these things, and what we need still, okay, so for that we will write down the expression for electric field intensity due to volume charge distribution. So electric field intensity at a point due to volume charge distribution is given by integral over v rho v dv by 4 pi epsilon r square ar bar. So I know what is r square, but I should write down what is ar bar. Okay, so if you look at the figure, so I draw this the reference point where dv is existing. Okay, so let us say this is dv, small differential volume dv. So dv is at r dash comma theta dash comma phi dash, small differential volume, and this is r dash, this is origin, okay, and this is z axis, and this is the vector r bar. This is what we have done. This is the point P, and if you look at this, if I extend this vector r bar in this direction, okay, so this gives me the direction of the unit vector ar bar, and if this angle is alpha, this angle is also alpha. So I can draw one more vector in this direction to complete this triangle. Okay, so now as this is alpha, now this is adjacent side, this will be cos alpha az bar, because this is in positive az direction, and this is opposite side, which will be, so what I get is sin alpha a rho bar. So that is what I will get. Okay, and from this figure, if you can see this, these two vectors, that is the tip of this vector is in contact with tail of this vector. So if I add this vector and this vector, I will get the resultant as this vector. So from the vector addition rule, what I can write down is ar bar plus sin alpha a rho bar is equal to cos alpha az bar. Okay, so from this, ar bar is equal to cos alpha az bar minus sin alpha a rho bar. Okay, and one more thing we will see here. So if you look at this ar bar, okay, so this is the unit vector for r bar, and now we will use all these things and substitute in the electric field intensity equation. Okay, so let us do that. So E bar is equal to integral over v rho v dv by 4 pi epsilon r square and ar bar, so which is cos alpha az bar minus sin alpha a rho bar. So this is what we are having. Okay, now we need to substitute what is dv bar is, so which is equal to, dv means we are having three parameters, r dash, theta dash and phi dash. So r dash is equal to 0 to a, theta dash is equal to 0 to pi, and phi dash is equal to 0 to 2 pi. This is the triple integral what we can write down, so which is rho v by 4 pi epsilon r square cos alpha az bar minus sin alpha a rho bar. So this is exactly what we are having right now into dv. So what is dv? R dash square sin theta dash dr dash d theta dash and d phi dash. So this is dv. Okay, now we can break this integral into two integrals, one with cos alpha az bar, one with sin alpha a rho bar. Okay, So let us break this into two integrals, right? So now, so E bar is equal to, so I will bring rho v by 4 pi epsilon outside. So what I got, and I will write down r dash equal to 0 to a, theta dash equal to 0 to pi outside, and now I'll keep brackets. So what is the third integral? Phi dash equal to 0 to 2 pi. First one is cos alpha az bar into dv, 1 by r square we are having. So 1 by r square, and now we are having the entire dv. Entire dv is what? R dash square sin theta dash dr dash d theta dash and d phi dash. So this is the first term. And now second integral, minus phi dash equal to 0 to 2 pi sin alpha a rho bar 1 by r square r dash square sin theta dash dr dash d theta dash and d phi dash. So now let us denote these two as, this is the first integral, this is the second integral. Okay, now let us consider the second integral alone. Okay, what is the second integral? Second integral is given by, so we are having, right, let me write this. So phi dash is equal to 0 to 2 pi sin alpha, and what is a rho bar? Cos phi dash ax bar plus sin phi dash ay bar, and rest of the things 1 by r square r dash square sin theta dash dr dash d theta dash and d phi dash. So now if I integrate this with respect to phi dash, these are the only two terms with respect to d phi. So if I go for this, everything is same, so that is sin alpha by r square r dash square sin theta dash dr dash d theta dash, everything. Okay, now if I integrate this, what I'll get? So sin phi dash ax bar minus cos phi dash ay bar over the limits of 0 to 2 pi. So if I substitute the limits of 0 to 2 pi here, sin 2 pi is 0, cos 2 pi is 1, so which is minus ay bar. Okay, so what we will get is some minus ay bar, and this is there already, and minus the lower limit 0, sin 0 is 0, minus of cos 0 again 1, so it is minus ay bar. So minus here, minus into minus plus, so answer becomes 0. That is, the second integral is becoming 0. We are left with only the first integral. Okay, right? So now the expression for electric field intensity, now after the second term is 0, rho v by 4 pi epsilon r dash equal to 0 to a, theta dash is equal to 0 to pi, and we are having phi dash equal to 0 to 2 pi cos alpha by r square az bar r dash square sin theta dash dr dash d theta dash and d phi dash. So if you look at this integral, there is no phi dash terms here. So if I integrate with respect to phi dash, I will get 2 pi outside. Okay, so rho v 2 pi by 4 pi epsilon r dash equal to 0 to a, theta dash is equal to 0 to pi, and cos alpha by r square r dash square sin theta dash dr dash d theta dash a z bar. So this is what I am having. Okay, now if you look at the previous things what we are having, we have sin theta dash d theta dash is equal to r dr by z r dash. Similarly, we have cos alpha is equal to z square minus r dash square plus r square divided by 2z r. So this is what we are having from previous results. Okay, right? So now we're going to substitute these things in the above integral. Okay, right? So now, so the electric field intensity, and one more thing before writing about that substitutions. Okay, so what we like to know is we have r square equal to z square plus r dash square minus 2z r dash cos theta dash. So this is what we are having earlier. Now if theta dash is equal to 0, then r square will become z square plus r dash square minus 2z r dash, which is z minus r dash whole square. That implies r is equal to z minus r dash. Similarly, if theta dash is equal to pi, then r square equal to z square plus r dash square plus 2z r dash, so which is equal to z plus r dash square. That implies, in this case, r is equal to z plus r dash. That means as theta varies from 0 to pi, r varies from z minus r dash to z plus r dash. So we have to use these results in integration. Okay, so with all these things I will write down the electric field intensity expression. So E bar is equal to rho v 2 pi, I will keep this 2 pi as it is, 4 pi epsilon, r dash is equal to 0 to a, and as I am going to replace, first let me write down theta dash equal to 0 to pi. So what I am having is cos alpha by r square, r dash square, sin theta dash, dr dash, d theta dash. So this is what I am having. Okay, so now we are going to replace what is cos alpha and what is sin theta dash into d theta dash. We will replace these things. Okay, right? And I think we are having az bar. Done. So now when we replace sin theta dash d theta dash with r dr by z r dash, we have to change the limits also. Okay, so rho v 2 pi by 4 pi epsilon, r dash is equal to 0 to a, next capital R is equal to z minus r dash to z plus r dash, and I will write this r1 dash square L first, r dash square by r square. Then I will replace sin theta dash into d theta dash. So what is that? R into dr by z small r dash, and then I will replace this cos alpha. What is cos alpha? Z square minus r dash square plus capital R square divided by 2z r. So I replaced cos alpha, and remaining things are dr dash and az bar. So dr dash az bar. Okay, now we will do some modifications here. So now if you see here, so what I get is rho v 2 pi by 4 pi epsilon, r dash equal to 0 to a, capital R equal to z minus r dash to z plus r dash. Now there is one r dash here, there is square here, one gets cancelled. Okay, similarly there is capital R here, there is also capital R here, these two get cancelled. Okay, so what I am left with is r dash divided by 2z square r square. So I am having 2 here, and there is 1z, there is 1z, so 2z square, and I am having r square here. Okay, right? And then, so this is in brackets. I will write down as first r square plus z square minus r dash square, bracket close, into dr and dr dash az bar. Okay, so this is what we are having. Now I will take this r square into this brackets. Okay, in the next step. Now the answer turns out to be electric field intensity bar is equal to rho v 2 pi by 4 pi epsilon, r dash equal to 0 to a, capital R equal to z minus r dash to z plus r dash. So what I am having is r dash here. Okay, so by 2z square, I will keep this, bring, let me write down first, r square plus z square minus r dash square dr dash is z bar. Now we will bring this r square inside. Okay, so rho v 2 pi by 4 pi epsilon r dash equal to 0 to a. So this is z minus r dash to z plus r dash. So r dash by 2z square. If I divide this, I will get 1 plus z square minus r dash square divided by r square, and close, dr dash is z bar. Okay. Now we would like to integrate with respect to r. So if I integrate that, so what I will get is rho v 2 pi by 4 pi epsilon r dash equal to 0 to a, because this is r dash by 2z square. If I integrate, so what I will get? So 1 dr will be r, 1 by r square will be minus r. So minus of z square minus r dash square by r, bracket close, over the limits of z minus r dash to z plus r dash dr dash is z bar. Okay. So if I substitute the limits, so what I will get is rho v 2 pi by 4 pi epsilon r dash equal to 0 to a, r dash by 2z square. So here what I will get is z plus r dash minus, because in place of r I will substitute z plus r dash. Here I am having z square minus r dash square. So this is a square minus b square. So I am substituting a plus b. So I left with a minus b. So which is z minus r dash. So that is upper limit. Minus the lower limit is z minus r dash. Okay. Minus into minus plus. I will get, now I am substituting z minus r dash in the denominator. So I will get a plus b, which is z plus r dash. Okay, so bracket close, dr dash is z bar. Now you can see z minus z, similarly here minus z plus z, here r dash minus of minus r dash, 2 r dash, here it is plus r dash, this is plus r dash, so 4 r dash I am getting. Okay, so finally E1 is equal to rho v 2 pi by 4 pi epsilon r dash equal to 0 to a, r dash by 2z square into 4 r dash dr dash is z bar. So this is the expression what we got. So as z square is doesn't depend upon integration, and I am having 4 here, so these 2 will cancel. So rho v 4 pi by 4 pi epsilon z square integral r dash equal to 0 to a, r dash square dr dash is z bar. So that is what we are having. Okay, right? So if I integrate this, rho v 4 pi by 4 pi epsilon z square r dash cube by 3 over the limits of 0 to a is z bar, which is what I can write down as 4 pi a cube by 3 into rho v in brackets 1 by 4 pi epsilon z square a z bar. Okay, right? So this is the answer what we got finally. If you look at this term inside brackets, so given is a volume which is nothing but a sphere of radius a. So what is its volume? 4 pi a cube by 3, and this volume of the sphere is multiplied by rho v, the volume charge density. That means this product of the volume of the sphere multiplied by volume charge density gives me the total charge enclosed in the sphere. Okay, so product of 4 pi a cube by 3 into rho v is nothing but equal to the q enclosed by the volume charge distribution. Okay, so what I can write down this expression as E bar is equal to q enclosed by 4 pi epsilon z square a z bar, where q enclosed is the total charge contained in the volume. Okay, right? So this is what we are having. Okay, sorry for the delay. This is the final expression. So electric field intensity due to volume charge distribution is given by q enclosed by 4 pi epsilon z square a z bar. Now some of the important things to remember here is this is the q enclosed by the volume. Don't confuse with point charge. Okay, so because in this case we have taken the volume as a sphere with radius a, so in this case the q enclosed is equal to 4 pi a cube by 3 into rho v. So where rho v is the volume charge density. And what is z? Okay, so if you look at the figure carefully, z is the distance between the origin and the point 0 comma 0 comma z. Okay, and that means z is the distance of the vector drawn from origin to the, so let us say this is origin and this is the point P, which is 0 comma 0 comma z in this case. So z is the distance of the vector drawn from the origin to the point of interest. So this is z. Okay, so in this expression, so your z is the magnitude of the vector drawn from origin to the point P, that is, this is simply the position vector of the point 0 comma 0 comma z. Okay, so z denotes the magnitude of the position vector of the point of interest, and az bar is corresponding unit vector. Okay, right? So in this expression of electric field intensity due to volume charge distribution, this q enclosed is the total charge inside the volume. Okay, and this z is the magnitude of the position vector of the point of interest, and az bar is the corresponding unit vector of the this position vector of the point of interest. Okay, right? So in general, so what we can write down is this expression as E bar is equal to q enclosed by 4 pi epsilon r square ar bar. Now this is the q enclosed in the volume, and this r is the magnitude of the position vector of the point of interest, and this is the unit vector of the position vector of the point of interest. So these are the important things to remember. Okay, so with this we completed the electric field intensity due to volume charge distribution. So first we discussed about infinite line charge distribution. For that the expression is rho L by 2 pi epsilon rho a rho bar. So in this case rho L is line charge density and rho is the distance between the point P and its projection onto the line charge, that is rho, and a rho is the corresponding unit vector. And for a infinite sheet of charge the expression is rho s by 2 epsilon a n bar. Here a n bar is the unit vector normal to the plane containing the infinite sheet of charge. Okay, so a n bar is the unit vector normal to the plane containing the infinite sheet of charge. So for a volume charge distribution, E bar is given by q enclosed by 4 pi epsilon r square a r bar. So here q enclosed is total charge in the volume, and r is the magnitude of the position vector of the point P. Okay, and AR bar is the corresponding unit vector. Okay, so these are the three important results, which is electric field due to line charge distribution, infinite line charge, electric field due to infinite sheet of charge, which is surface charge distribution, and electric field due intensity due to volume charge distribution. Okay, right? Thank you.